Hello, and welcome to the first episode of UnEarthing Data. I'm Dr. Brad Hegyi, the data advisor for MyNASA Data. In this series, NASA scientists, such as myself, will take you through the thought process we use when we analyze data in our own work. We will give you some tips to help you in some of your own data explorations. So today we're going to focus on the phytoplankton scientifically interesting story, which is phytoplankton blooms in the polar regions. So let's start our dig and see what we can find. In the first part of this episode, I'm going to give a guide to interesting stories that are hidden in the data. These include interesting patterns and other features of the phytoplankton data. In the second part of this episode, which will be a separate video, we're going to join the dig. We're going to learn how to use the Earth System Data Explorer to find hidden data gems in both the phytoplankton data and other data sets that are available on the Earth System Data Explorer, which is a part of the MyNASA Data website. Also in this episode, we're going to go over the 5 steps to a successful data dig. In part 1, we're going to first go over step 1, which is preparing for the dig. Then we'll go over step 2, which is understanding the data that describes the phenomenon that you're interested in. And throughout this presentation in part 1 and part 2, anytime you see the light bulb icon, this is a data tip. And look for these to help you in each of the steps that are presented. And this icon will appear in next to each of those tips in each slide. So look for these as helpful reminders and pointers to help you be more successful in your dig. In part 2, we will go through the other 3 steps, which are going to be asking the right scientific questions, and then we're going to answer those questions with evidence, and then we're going to create a data picture. And we're going to take our results and what we learn by looking at the data and try to fit it in our picture or our model of the phenomenon and how it works.
In the first step, we are going to get ready for our data dig. I would suggest that you either gather a notebook or open a document on your computer to take notes. Having either of these ready to take notes will help us remember and record what we see when we start digging. We'll be answering several questions along the way to help us understand the data as we're looking at it. Next, we need to figure out what our first data set will be. We need high quality data to analyze, and the data needed to come from a trusted source. At MyNASA Data, we do a lot of this work for you, bringing you high quality data from NASA missions and other reputable sources on our Earth System Data Explorer.
So let's start our dig and look at the first data set. I'm going to start with the chlorophyll concentration data from the Earth System Data Explorer. And you can find these data under Biosphere, All Data, Vegetation, and Chlorophyll. This data describes the chlorophyll concentration across the world's oceans. And since phytoplankton use chlorophyll to make their food, areas of high concentration of chlorophyll mean there are a lot of phytoplankton present in that part of the ocean. The data are global, and they cover a time period from 2012 to near present.
The first map that I'm looking at is the monthly chlorophyll concentration from January 2012. Let's take a moment to look at this map and notice any patterns that we see. Here are some starter questions to help us wrap our heads around what this map is showing. First question, where are the minimum and maximum values? Looking at this plot, the maximum values, which are in yellow, are found along some of the coasts and in the oceans south of 40 degrees south latitude. The minimum values, which are the dark areas on the map, are found in the middle of the oceans around 20 degrees south or 20 degrees north. These 2 regions are known as the subtropics. Question 2. Are there any interesting patterns or features on the map? I see many interesting patterns that we could talk about in this episode, but I'm going to focus on 4 of them. These 4 patterns, I think, are the most important patterns to better understand the phytoplankton phenomenon. The first set of interesting patterns or features that I see are high chlorophyll concentrations along the coast of some of the continents, but not others. I outline some of these features here in the color boxes. Here's what the features look like zoomed in. You can see that there's one area off the Asian continent, one area off the African continent near the Sahara in North Africa, and a third area that's off the coast of Patagonia in South America. We will try to explain what causes these patterns in part 2 of episode 1.
Second interesting feature I see is across the subtropics, and that is that there are very low values in the middle of the ocean, especially around 20 to 30 degrees north and 20 to 30 degrees south latitude. Now here, to create this map, I changed the color scheme and the range of the data, and this can help highlight certain patterns in the data. So in this map, I changed the color scheme to magma, which made the areas of low chlorophyll values very dark, and I reduced the range to show areas of low chlorophyll concentration. So this is a technique that you can use to help in your data exploration. The third interesting feature I see is that there are higher values in the southern hemisphere more than the northern hemisphere in January, especially near the polar regions. So here I only show the areas north of 30 degrees north and south of 30 degrees south. You can see the southern hemisphere has more bright colors, which means that there are higher concentrations of chlorophyll compared to the northern hemisphere this time of year.
The last interesting feature is a thin area of maximum chlorophyll concentration values along the equator. This maximum is especially visible in the Pacific Ocean. Here is a map zoomed in along the equator in the Pacific Ocean, extending from South America on the right to Indonesia off the map to the left. You can see that if you follow along the equator, there is a maximum value of chlorophyll concentration. This is another interesting feature in the map. Patterns that are oriented east-west, like this one, and patterns that are oriented north-south are common in Earth data. If you ever see these patterns in your data, it is something definitely worth investigating.
So to summarize what we can see in the one map from January 2012, we can see high concentrations of chlorophyll along some coasts, but not others. We see low concentrations in the middle of the ocean, especially in the subtropics. We see higher values near the polar region of the southern hemisphere when comparing that region to the polar regions in the northern hemisphere. And we see higher concentrations along the equator. So the next question is, do these patterns occur during other parts of the year? And are they patterns that stay the same, or do they change over time? So now we're going to look at some animations to answer those questions. But first, before we do the animations, one set of useful plots is to take maps from each season and see if the patterns change between seasons. So here I have a map from January, which would be winter in the northern hemisphere, April, spring in the northern hemisphere, July, which is summer in the northern hemisphere, and October, which is fall in the northern hemisphere. So if you look at these four maps, you can see some evidence of what patterns change and what patterns don't. For example, if you look across the Pacific along the equator, it seems that that pattern doesn't change. But if you look at the southern hemisphere, you see that that pattern changes over time. And then in fact, in the summer, there's a lot more chlorophyll concentration during the summer months. And now we're going to see that in an animation. So what I have here is a map. This is an animation showing the chlorophyll concentration over 1 month or over 1 year in 2012. So I'll play the video again and focus on a pattern that we talked about earlier. So for example, if you look at the subtropics, you see these black areas don't really change too much through the year. So this pattern is pretty stable. If you look along the equator, you can see that this line along the equator changes a little bit, but overall the pattern is pretty stable. And finally, I'll play it one more time. If you look at the southern hemisphere, the polar regions, you can see that the high concentration of chlorophyll disappears during July and August. And if you look up north, in the northern hemisphere, you see the high concentrations appear, especially in April through July in the oceans in the northern hemisphere around the polar regions. So this animation shows what patterns are changing and what patterns are staying the same.
We now zoom in closely to a couple of these patterns. You can see that the equatorial pattern is consistent throughout the year. The pattern of high concentration values in the Southern Ocean north of Antarctica decreases in June and July, and then increases again at the end of the loop in November and December. These two patterns behave differently with time. The pattern along the equator is rather stable. The pattern near the poles is cyclic or seasonal. Chlorophyll concentration values increase during the summertime near the poles and decrease during the winter.
In today's first part of the episode, we analyzed the chlorophyll concentration data set. We went ahead and picked it from the Earth System Data Explorer, and we began to look at patterns that existed in the data. So we described the data, we identified patterns in a single map, and then we identified which patterns are stable and which are seasonally changing in an animation of the data, and by also looking at a 4-panel plot with 4 maps, one from each season. So in part 2, we're going to continue looking at chlorophyll data, but we're going to start asking questions of the data. We're going to ask why. Why do these patterns exist? And then we're going to use evidence to answer our questions from the Earth and use evidence from the Earth System Data Explorer. So I hope that you can join me for part 2, and I hope that you enjoyed this first part and got something out of it to help you in your data dig and your data exploration. Thank you.